Hello, calculus folks. I'm going to go through the notes for 3.4a, which is the product rule. Basically, you learned, your old rule you already learned was called the power rule. And that is kind of the building block for all our other rules. We're going to get 3 more cool rules that use this rule in it. So you have to be good at this. That's why we spent 2 days on it. Even if it's not that hard, you can't mess this part up because it's a part of all the other derivative rules. Remember what a derivative is. A derivative finds the slope, the instantaneous slope, or slope at any point on a line. Okay, so the old power rule was if you take the derivative with respect to x, that's what this means, take the derivative, of x to the n power, it brings the n in front and multiplies it by x to the n minus 1. It takes the power down a notch there. So the new rule is this. It's called the product rule. And basically, the product rule is whenever you are taking the derivative of a function times a function. So if you have f of x times g of x, okay, what that's going to equal is regular f of x times g prime of x plus regular g of x times f prime of x. So basically, if you notice, there are 2 functions here. In one of them, the g is derivatized, if that's a word. It's a g prime. And the other one, the f is derivatized, and there's a plus in the middle. So you're basically spreading out the derivative to each part. And that's what it equals when you do the product rule. You've done some problems before that could have used the product rule, but we distributed ahead of time so you didn't have to. You're going to see today there's a quicker way. Alternatively, here's another way to write it. A lot of people like this, except for the fact we do tend to use u's and v's in here. But u v prime plus v u prime. Okay, it means the same thing, right? 2 different functions. You prime the v, then you prime the u, and you have a plus sign between. That's your new rule. Now let's try it out. Let's try it out on an easy one. Okay. An easy one would be like this, because I wouldn't have to use the product rule on this. I could just multiply these out ahead of time, right? Like we know how you could do this problem already before doing this. You'd multiply those 2, get 15. Actually, I kind of want to do this ahead of time. In the past, you would just go 15x to the 6th, and then the derivative of 15x to the 6th is whatever 6 times 15 is. So 6 times 15 is 90, x to the 5th, right? That's the way you would do it before. Now, what you want to think of this guy as f of x, and you want to think of this guy as a separate g of x. You'll see you could also do this problem like this. The derivative of y is regular f of x times g prime of x plus regular g of x times f prime of x. So now I'm going to substitute in. Okay, f, you just write it as normal, right? So 5x squared. And then what's the derivative of just this part? That would be 12x to the 3rd, right? And then here I'm going to write g of x as it was. That's 3x to the 4th times f prime of x. So I'm just going to take the derivative of that, which is 10x. And then you'll see I can simplify this because 5 times 12 is going to be 60. X to the 5th, because x squared times x third is x to the 5th. And this one is 3 times 10, which is 30. And we have x to the 5th, which gets you to 90x to the 5th. Now, which way was quicker? Holy cow, this way was quicker. So you don't have, just because you see multiplication doesn't mean you have to use the product rule. Sometimes it's quicker to multiply. But I promise you, this rule is here for a reason. And that reason is it usually saves you a lot of time. Okay, so let's look at this one. Example 2. So we're going to go with, what if you had a problem like this? F of x equals x squared minus 2x plus 1. and x cubed minus 1. Okay. So for this one, we're going to go with like, call this u and call this v. I'm just trying out both these things. So f prime of x would equal u times v prime plus v times u prime. Okay, so let's try that out. F prime of x is going to be, what's u? Just regular u, x squared minus 2x plus 1. And then v prime is just going to be 3x squared. Remember, the derivative of the 1 goes to 0. So 3x squared. And then I have a plus sign. And then I write v just as it is, x cubed minus 1. And then I take the derivative of u, right, because u prime. And that's going to be, what, 2x minus 2. And the 1 goes to nothing. Okay, so this technically is the derivative, because that's u, that's v prime, that's v, and that's u prime. Now, if I asked you to find the slope, you could plug in, like if I asked you to find the slope at when x equals 1 for this graph, you could just plug a 1 in here, here, and get the slope. If I ask you to, sometimes I'll ask you to simplify, and then I'll want you to actually distribute it out. So that would be 3x to the 4th. Multiply it here, you get minus 6x cubed plus 3x squared. Then here you got a FOIL. So first is 2x to the 4th. Outer is minus 2x to the 3rd. Inner is minus 2x. And last times last is plus 2. And then we can combine like terms. See those two guys go together and make 5x to the 4th. These two guys go together and make minus 8x cubed. This guy goes with nothing, I guess. Okay, everything else goes by itself, minus 2x and plus 2. So that's your final answer. Now, but let's take this one step further and say, what if I wanted the slope of f of x when x equals 1? Okay, all you do, well, I don't have to do anything with f of x. I don't even have to know the y value. All I got to do is plug a 1 in here. Because f prime of x finds the slope at any point. So if I want f prime of 1, I mean, I'm asking for the slope when x is 1. That's 5 times 1 to the 4th. That's minus 8 times 1 to the 3rd. Plus 3 times 1 to the 2nd. Minus 2 times 1. Plus 2. That's really 5 minus 8 plus 3 minus 2 plus 2. Right, those go away. 5 minus 8 is negative 3, and so that's 0. So that means the slope is 0 when x is 1. So that's kind of like I could write the equation of a tangent line and all that stuff before. Now, is that the same answer you would have gotten if you would have FOILed this out and then taken the derivative? Yes, it is. So product rule sometimes can be avoided. Not always, though. Now, here's example 3 for the product rule. You can see a product because these are multiplied together. Now, could I distribute? Yes, but what I really notice is this guy, and I don't like it in the bottom, so I want to rewrite this because the product rule uses the power rule, and the power rule works better if I write it like this before I take the derivative. So here I got this guy times this guy. Notice I didn't write f prime of x because all I did was a rewrite. I didn't take the derivative yet. My directions are find f prime of x and f prime of 1. What does that mean? That one right there means the derivative. I want to know the slope when x equals 1 of my original graph. So now I'm going to do the product rule. If this is u and this is v, I have u times v prime, which is negative 2x to the negative 3. Don't rookie that one up. Plus v times u prime, which is 5x to the 4th minus 3. Okay, now I can plug a negative 1 in right now and get the right answer. Or I could simplify. Just watch what I say for directions, because sometimes I want you to simplify and sometimes I don't. Okay, so maybe this time I want to simplify. Bring that in there. And I guess it's good practice anyway, because when you multiply these, you add their exponents. So I got negative 2x to the second power. Okay, minus, not minus, plus 6, because you got a negative 2 times negative 3, x to the negative 2 power. And here I'm going to distribute that guy, and I get 5x to the third. Oh, not third, that's second. I can add. And here you got minus 3x to the negative 2. And then maybe I'll rewrite stuff or combine like terms. I got this squared and this squared to make 3x squared. And I got this guy and this guy, which is 3x to the negative 2. Maybe I'll rewrite that just to make it pretty again. You don't always have to do this, just watch what directions say. If it said simplify completely, I'd want you to do that. And then finally, we got, we can plug in a negative 1 from up here. So f prime of negative 1 is 3 times negative 1 squared plus 3 over negative 1 squared, which is going to be 3 plus 3, 6. So the slope is 6 when x is negative 1. See that? All right, one more weird thing. All right, so here's the last thing. You can also apply the product rule if there are more than 2 functions being multiplied. Every example I've shown you so far was just 2. But I wanted to tell you it works for 3, it works for 4, it works for 5. It just gets crazy as you go. So if I want the derivative of this times this times this, u times v times w, you basically are going to write u times v times w prime plus u times v prime times w plus u prime times v times w. Notice each time it kind of cycled through who was the derivative and who wasn't. So you only have one derivative, and you got to make sure every piece gets its own, and there's always plus signs in the middle. You can see how this would apply out to 4 and 5 and 6. So on this one, let's say I asked you to find the derivative of this guy, right? I don't want to FOIL that out. That would be brutal to FOIL out. So I just have to keep track of which one's which, and when I do the derivative of the product rule, I just have to be careful that I don't do anything to 2 of them, and I kind of cycle through which one I take the derivative of. Like this first time, I'm going to do the derivative of this guy, which is 2x plus 1. And then my next time, I'm going to write this guy normal. I'm going to make my middle one the derivative, and I'm going to write the last one normal. Probably should have written smaller than this. So what's the middle one derivative? V prime will be 2x. That's it. And then the last thing, this would have been on the same line if I had room. The last time, I'm going to write the first one as a derivative, and the last 2 is normal. So it takes a little extra practice, a little extra attention to detail to make sure you don't miss something. So the derivative of the first guy is going to be 2x minus 1. Now, this would be a mean problem if I said simplify it completely. Holy cow, that's a lot of foiling. You're going to foil that, foil that, foil that. If I told you to simplify this problem completely, man, I would have just foiled at the beginning, and then you'd have power rule, power rule, power rule. But I did want to show you, I could easily still answer the question, what is the slope of f of x when x is 2? I don't have to simplify this completely to find the slope. I just have to plug a 2 in everywhere you see an x. Now this is going to get crazy. And I don't think I have time on this video to do that, but you can find the slope just by plugging that in. I'm going to pause here so I can show you the end result, because I know you can plug 2's in. Okay, so if you put a 2 in everywhere up there and type it into your calculator, in one crazy big line, you get slope of 211, which is, that's pretty close to vertical. All right, anyway, that's the product rule. Get used to it. It's an awesome rule, and the power rule is used throughout. So next time, we're going to divide, not multiply. Talk to you later.